Okay, so we have this question dealing with Cramer's rule, right? We're using Cramer's rule to solve this simultaneous equation. Okay, remember in high school, simultaneous equations, there'll be two variables, x and y. Now, here, there are three variables, x, y, and z. So we can't use the traditional methods of elimination method and substitution method. All right. So you can use Cramer's rule. Okay. Well, we're going to solve this simultaneous equation using matrices. Okay. So we have this equation here, x plus 2y plus 3z equals 17. 3x plus 2y plus z equals 11. X minus 5y plus z equals negative 5. Okay, so I'll show you the steps of Cramer's rule. All right. So before you start any of the steps, okay, you need to form the matrix. Okay, you need to form the matrices here. Okay, so our matrices will be like this. Okay, this first matrix is going to be the coefficients matrix. Colleagues, a coefficient is just a number in front of a letter. Okay, so we're going to first look at this focus on the x column here. Okay, in equation 1, we've got x here, so the coefficient is 1. In equation 2, we have a 3x here, so the coefficient is 3. Okay, in equation 3, our x has a coefficient of 1. All right, we come to our y column here. Okay, so here we've got a positive 2y, so we're going to put 2 here. Another positive 2y, so we put 2 here. And then negative 5y, so we put negative 5. Okay. Then for our z column, this is the x column, y column, and z column. Our z column, here we have a 3z, so we put this coefficient 3 here. A z here, so we put a coefficient of 1. Another z here, we put another coefficient of 1. Okay. This is the coefficients matrix. Are we okay with this, colleagues? Any questions? This is the matrix you need to form. Okay. Then you're going to make a constants matrix. The constants, what I mean are just these numbers here after the equal sign here. 7, 11, and 15. Okay, you're going to make this matrix. 17, 11, and negative 5. Okay, so these are the matrices we'll be dealing with. Okay, so now we go to the steps. Okay, step 1. Okay, get the determinant D. Determinant D. Okay, so how we're going to get this determinant, we're going to use our coefficients matrix. All right, so let me write it down here, the coefficients matrix. We're going to have 1, 3, 1, 2, 2, negative 5, and 3, 1, 1. Okay, so take note of this process because this process we're going to be doing it throughout. So after we make this matrix here, the first two rows, the first two columns, this column 1 here and this second column here, column 2. Okay, you bring them outside of the matrix. So here 1, 3, 1, and here you have 2, 2, -5. Okay, colleagues. For every matrix, the first two columns should go outside. Okay. Yes. Now we can start our tabulations for getting our determinant. Okay. So when dealing with this question in the exam, have at least a blue, a black pen, and a pencil so that you can solve properly. Okay. So we're going to start with our diagonals. We're going to multiply the diagonals across this matrix, right? So this is what I mean. We're going to multiply 1 by 2 times 1, okay? 1 times 2 times 1, that is 2, okay? We go to the next one, the next diagonal. We're going to say 2 multiplied by 1, that is 2. 2 again multiplied by 1, that gives us 2. Okay, so here you put plus here. Plus, we'll go to the next diagonal. 3 multiplied by 3, that is 9. 9 multiplied by -5, that is -45. Okay. So 2 plus 2, that is 4. 4 plus -45, that is -41. Okay. Yes. Then we go to our next diagonals. We're moving like this, where we say 1 times 2, that is 2, multiplied by 3. So 1 times 2, 2. 2 times 3, that is 6. Okay. Next diagonal, -5 times 1, that is -5. -5 again times 1 again, that is -5. Okay, here 6 plus -5. Then our last diagonal, 1 times 3, that is 3. 3 times 2, that is 6. Okay, colleagues? Yes. So make sure when you do this process, have you seen this 3 in the middle? It hasn't been touched by any diagonal. And this 2 also in this middle here. Here and here. These shouldn't be touched by any diagonal. Then you know that you've done the process correctly. So 6 plus -5, that is 1. 1 plus 6, that is 7. Okay. So to get our determinant D, you're going to say -41. So always bring the number at the bottom first. Okay. -41 minus 7. -41 minus 7. That gives us -48. Okay, that is our determinant. Okay, so this process of Cramer's rule here, we're just going to be getting determinants and we'll be using this same process. Okay, you're just going to be multiplying the diagonals and then you get the determinant. Okay, yes. Any questions before we go to step two? Okay, we are looking at this assignment question here on Cramer's rule. Okay, so just follow along. I'm recording this video, okay, madam? I'm also recording this video. So just follow along and just see how the process is the same throughout. Okay, so um, yes. All right. Step two, get the determinant of x. Okay. Now, once you start getting the determinants of the letters, this is where this matrix will come into play. This 17, 11, and -5. Okay. When we were getting the overall determinant, we never included this matrix here. But once you start getting the determinants of the letters of the variables, we are going to bring in this matrix. We're going to include this matrix in here. Okay. So for the determinant of x, what is going to happen is this matrix is going to substitute this x column here. Okay. This matrix, the constant matrix, is going to replace this x column here. Okay. So our matrix is going to read this. Okay. So we're going to put the 17. So in the x column, we're going to put the 17, 11, and -5. Okay. Then the y column stays the same, 2, 2, -5, 2, 2, -5. And the z column stays the same, 3, 1, 1. Okay. Yes. Then as always, the first, once you made your matrix here, the first two columns need to come outside. So here you put here 17, 11, -5, 2, excuse me, 2, -5. Okay. Yes. Then we start multiplying now the diagonals. You can start with the top diagonals or the bottom diagonals, whichever. Okay. So we'll start 17 times 2, that is 34. 34 times 1, that gives us 34. Plus 2 times 1, that is 2. 2 times -5, that is -10. So in the exam, take extra caution, okay, especially with these negatives and positives. Mm, you don't want to mess up. Okay. Then here we have 3 times 11, that is 33. 33 times negative 5. We get negative 165. Yeah. So we are going to say 34 plus negative 10, which is the same as 34 minus 10, plus negative 165, the same as minus 165. And you're going to get negative 141. Okay. Yes. Then we go to our next diagonals, starting from the bottom going up. 5, negative 5 times 2, that is negative 10. Negative 10 times 3, that is negative 30. Plus negative 5 times 1, that is negative 5. Negative 5 times 17, that is negative 85. Plus 1 times 11, that is 11, times 2, that is 22. Okay. So you're going to say negative 30 plus negative 85 plus 22, and get negative 93. Okay. So our determinant for x, which we'll call dx, okay? Dx is the determinant for x. It's going to be negative 141 minus negative 93. Okay. So negative 141 minus negative 93, we get negative 48. Okay. Yes, that is step 2. Step 2, get the determinant of x. Okay. Yes. Any questions before I move to step 3? Step 3, get determinant of y. So here, when getting the determinant of y, our y column here, our y column is going to be replaced with this 17, 11, negative 5. Okay. The y column will be replaced with this matrix here, 17, 11, negative 5. Okay. So just get the numbers here. So we make the matrix. Our X column, as you can see here, 1, 3, 1. Our Y column, replace it with 17, 11, negative 5. Then our Z column stays as it is, 3, 1, 1. Okay. Yes. And then as always, the first two columns come out. So here, this 1, 3, 1, and this 17, 11, negative 5. Okay. Then we start the diagonals now. So you say 1 times 11, that is 11. 11 times 1, that will give us 11. Plus 17 times 1, that is 17. 17 times 1 again, that is 17. Plus 3 times 3, that is 9. 9 times negative 5, that is negative 45. Okay. So 11 plus 17, 11 plus 17 minus 45, negative 17. Okay. And we go to our next diagonals, going from the bottom up. You're going to say 1, okay, this is a 1, not a 7. 1 times 11, that gives us 11. 11 times 3, that is 33. Plus negative 5 times 1, that is negative 5. Negative 5 times 1 again, that is negative 5. Plus 1 times 3, that is 3. 3 times 17, 3 times 17, that is 51. So we're going to say 33 plus negative 5 plus 51, 79. Okay. Yes. So our determinant of y, dy, okay, remember colleagues, always the bottom number comes first. because you might make a mistake, put the top number first. So you're going to say negative 17 minus 79. Negative 17 minus 79, we get negative 96. Negative 96. That is our dy. Okay, that is step 3. Then finally, we go to step 4. Get the determinant of z. Okay. So this matrix here, this 17, 11, negative 5, is going to replace now the z column. Okay. It's going to replace the z column. Okay. So we first put our x column here. One, 3, 1. Then we put our original y column, 2, 2, negative 5. 2, 2, negative 5. And then now our z column gets replaced with the 17, 11, negative 5. Okay. So as always, the first two columns, you put them outside. 1, 3, 1, 2, 2, negative 5. Okay. So we start getting our diagonals now. 1 multiplied by 2 multiplied by negative 5. So 1 times 2, that is 2. 2 times negative 5, that is negative 10. Plus 2 times 11, that is 22. 22 times 1, that is 22. Plus 17 times 3, that was 51. 17 times 3, 51. 51 times negative 5, that is negative 255. Negative 255. Okay. So we're going to say negative 10 plus 22 plus negative 255. We get negative 243. Okay. Negative 243. Negative 243. Then we get our next diagonals. 1 times 2, that is 2. 2 times 17, that is 34. Plus negative 5 times 11, negative 55. Negative 55 times 1, negative 55. plus -5 times 3, that's -15. -15 times 2, that is -30. Yeah. So we're going to say 34 plus -55 plus -30, you get -51. Okay. Remember here, positive and negative make negative, so it's like 34 minus 55. And here, positive and negative make negative, so it's like 34 minus 55 minus 30. You get -51. Then dz, determinant for z. Remember, the bottom number comes first. -243 minus -51. Okay. -243 minus -51. So it's the same as -243 plus 51, because negative and positive make negative, -192. Okay. You just put this properly for study's sake so that you don't get confused with the number that was used here. -51. Yes. So -243 plus minus -51. Negative and negative make positive, so the same as -243 plus 51, we get -192. Right. Now that we're done with getting all the determinants, we are now able to get the values of x, y, and z. Okay, so we can call this step 5. Get the values of x and y and z. So to get the value of x, it's going to be dx, the determinant of x, over the overall determinant d. Okay. Remember, our overall determinant is -41. The determinant of x is also -48 here, overall determinant, which is just d, -48. Determinant of x also -48. So we're going to say -48 divided by -48, that gives you 1. So x equals 1. For y, you're going to say dy divided by d, the determinant of y divided by the overall determinant. Remember, the determinant of y was -96. So you say -96 divided by the overall determinant, -48. Okay, so you're going to say 96 divided by 48. -96 divided by -48, that is 2. Okay. Then z. Okay, z is dz. Okay, I'm going to say dz divided by d, overall determinant. The Z is negative 192 divided by negative 48. Negative 192 divided by negative 48, you're going to get positive 4. Okay. So the value of x is 1, the value of y is 2, and the value of z is 4. Are there any questions? Okay. So now you can prove if your answer is correct, all right? You can pick any of these equations, okay, to test if your answer is correct. So let's pick this equation here. X plus 2 plus y plus 3z equals 17. Remember, x equals 1. So here we're going to say 1 plus y equals 2. So 2 times 2. And z equals 4. Okay. Remember, we're following this equation. X plus 2y plus 3z. We have to get a 17. 2 times 2, that is 4. 3 times 4, that is 12. 1 plus 4, 5. 5 plus 12, 17. So you will know that your answer is correct. Okay. You can try it in any of these equations, the values that you get, to make sure your answer is correct. So as we can see, the equation holds true. So that is the answer.